Hello and welcome to another water drop workflow video where we're going to be looking at real-time controls in InfoWorks ICM. This is kind of the third installment of this series, just looking at some different RTCs. So this might look familiar from some of the previous ones that I did, but who is this for? Engineers wanting to represent RTCs in their system, ICM users that want a crash course using a handful of different RTCs that they might not be familiar with, and then also InfoWorks ICM users that want a more realistic and accurate model. The two RTCs we're going to look at today are using variables to compare values to empty two tanks, and then we're also going to define the operation of a regulator based on the cumulative flow past a point. In this example, we're going to be looking at the different levels in tank D and I to determine which orifice is opened over one another, while also looking at H1 again to make sure that neither are releasing, or at least they're reducing their flow if the flow in H.1 is exceeding a certain amount. So pulling up the RTC editor here, there are numerous global ranges and rules and things like that that need to be set up first. So we're going to go insert a new range to start out with. This is going to be tied to the flow in H1. So this is going to set the highest amount of flow that we want to have going through here. And this is going to be later on used in our rules to be able to make sure that neither are releasing or they're being reduced once we get to that point. So 0.58 cubic meters per second are going to be the amount of flow that we want to limit things to. So just having that set up there. Next on, we're going to look at the levels in each one of the tanks. So level in tank D, it's just going to be the height above the datum. And looking at the tank D, that's all we'll do there. And these are going to be used in the next step when we're setting up the comparison variable to get an idea of which tank needs to be released first, or which one needs to be ramped up. So level in each one of those. Next is going to be the variable. So this is what we're going to be able to use to compare those two values. Looking in here, we're going to just name it comparison, and the operator is going to be minus, where we're subtracting the level in tank D by the level in tank I. Next up, we need to set the levels at which we want one to either change or decrease from flow from one to the other. So this is again going to be set up so that we're looking at the D tank to release more flow. So we set up the type as variable, and we're looking at comp with a minimum value of 7. So essentially, if the difference in the level in the tanks is greater than 7, then we'll have D flowing more, is what we'll end up setting up with our new rules there. If we want more coming out of I, we set that up by again selecting the variable, selecting the comp, and then setting the maximum to 7. So anything that's less than 7, we'll be able to set it up so that it's I would be releasing more. Next, the dependents are going to be logical expressions. So this is going to be one that's set up to increase or up D, increase the flow coming from the D tank. So looking at up flow, again, just making sure that our flow isn't exceeding that 0.58 through the H, and then D more if that level is greater than 7, having that released as well. Another logic we'll have set up in here is to ramp down the amount of flow coming from tank D. So this is going to be, again, down flow. So again, if the amount of flow is exceeding that, then we're going to ramp down. And then again, with the I more, having that as a true statement, if the difference in head between the two is greater than 7 or less than 7. Next, we're going to set up the similar controls for I. So we've got an AND condition there as well, where we've got upflow, again, limiting the amount of flow, and then for the more, increasing that, we're going to have that set up there. So, whoops, not range, but setting up one last logic for ramping down flow coming from the I tank. Again, the flow coming from there, making sure that it's below that 0.55 in that link, and then setting it up so that if the head difference is there as well. So finally, we end with a controller just to get some changes based on a certain time period. So this controller is just going to be set up as an incremental controller, so just a measurement every 300 seconds. Finally, we're ready to insert the regulators for tanks D and I, starting off with D. This is going to be set up so that the rates of change are 1 cubic meter per second, and then setting up the rules for the different conditions here. The first one being increasing the flow. So if we go back to our logic, increasing the flow based on that logic parameter, we are going to use a control, and the control we're using is that one that we just set up there. So update that, and that's good to go. We're going to insert another rule for ramping things down. So going back to what we had set up in the logic, setting up the controls, and the controls there to, oh, and I forgot the increment, decrement. So down is going to be reducing the flow by 0.01, and then the upflow, I forgot to add this in. So we're updating that. So using the incremental controller, and if we go up here to understand what's going on, unless subsequent rules are true, the flow at the upstream link is less than 0.58, and the value of the comparison between the two tanks is greater than 7 feet, then D2 will slowly increment up and increase the flow by 0.01 cubic meters per second. If the flow is greater than 0.58, or the difference, and the difference between the two is less than 7 feet, then it will start to decrease. Adding in our second regulator for I2, we need to set up the rules associated with these, setting our rates of change of 1, and then with this rule, again, it's going to be using this logic that we had set up, along with the controls and the amount of flow we want to change it to. So if we look at the description here, so again, the flow in H1 being less than 0.58 cubic meters per second, and the difference between the two tanks is less than 7, then it will start to increase the flow coming through link I.2. You'll notice here too that the description for decrementing it is the same that we had for decrementing, where if the flow is greater than 0.58, so in either one of these cases, if the flow is greater than 0.58, we will see some we will see decreases in each one of the two. closing this out now and taking a look at the results that we already have here. Dragging this workspace on to pull up a couple of graphs here. So we can see the orifices D.2 and I.2 in here, along with the amount of head in each one of the tanks, D and I, and then also here on the right, the amount of flow going through H.1. You can see that we start off at 0, and so we get a little bit of flow coming out of I because the difference between the head isn't greater than 7, but then we reach 0.66 flow going through there, and as a result of that, we don't see any flow coming from either tank until right around the 8-hour mark is where we start to pick up some flow coming from the orifice, or the D.2 orifice, around that same time that we see the decrease in flow coming from H1, because we had some extra flow essentially coming from other parts of the model. You can see that we're steadily hanging in here with that kind of 0.58 value. As such, as we're kind of bouncing around, you see the regulators turning on and off. Once that drains out, the head begins to no longer be greater than 7 between the two, and that's where we can see the orifice I.2 start to open right around that same time where we're seeing it shut off and shut on. That's when the head starts to become different than the head difference between the two becomes less than 7. So you can see it's kind of matching those peaks and valleys, and then once we do get to the point of fully that we no longer have that 7 feet of head between the two, orifice I starts to open up right around that same time. In this example, we're going to be looking at an RTC that is set up to swap the gates depending on certain criteria that we've set up based on the cumulative flow past a point. So in here we have this overflow weir set up at 13.2. We have 2 variable sluice gates here set up at a lower elevation, where these are going to be controlled based on some different parameters that we end up setting up. The idea being we can divert water from one area to another based on certain criteria. So pulling up the RTC editor here, we are going to set some global ranges and things like that. So right here, this is going to be just an indication of when it rains. The idea is to be able to build this out so that once rainfall has exceeded a certain intensity, in this case we're going to use 4 millimeters per hour, we're going to end up flipping the gates. So next we need to insert a variable. So this is going to essentially tell us how much time this can be true before the next rule is enacted. So we're just going to name this timer 1. And the idea here is that we can use this in order to set the amount of time it takes to get that it can be true before we do swap those. So just starting with the rainfall there. Finally, finishing it off with a second range. And this is going to be in order to swap the gates between the two. Once we get that set up, we can change this to look at that variable that we just set up and have it defined as 10 seconds. So once 10 seconds is passed at an intensity of 4 millimeters per hour, that's when it'll end up swapping the gates once we set up our rules here. Next up, we need to choose those regulators. So 130.1. With the rules in here, we are going to set up the default to be open. So in here, default, it's just going to be the position, and we're just going to have it open at 0.5 meters. When we want to swap the gates after that 10 seconds at that particular intensity, we set up a second rule for that, where we are going to be swapping the gates and changing that position to now 0. I'm going to add in the next regulator at 100.3. The default for this controller is going to be being closed. So just again, the position being 0. And then next up is when we do get to the point of swapping the gates, then we will open it. Next up, we'll need to set up a range for where we're looking at the flow. We are looking at the flow through our through 130.3. So just naming that flow and looking at that length that we want to make sure that we're looking at in order to see what cumulative flow we have past it. Next up is going to be setting up the variables where we're going to be doing those calculations, calculating the amount of cumulative flow. So TS cum flow is what I'm going to name it. And then within this dialog, we do times, and it's going to be our range that we just set up, the flow 1, and that's going to get multiplied against 60. So it's a 60-second time step. So the time step needs to be 60 seconds when we do run the simulation. Next up, we are going to add all of that together. So again, another variable where this is going to be the total amount of flow going across here. Measurement is still none, and we are going to add the cumulative flow plus the total. That's not listed there just because it's a new variable, but it's in there now. So. Alright, so moving on here on to our next set of another range to be able to specify how much of the total can go through here. So this is going to be, in order to close, this is going to be set up on the variable that we just included here, the total amount of flow getting past this, and essentially if we reach 350 cubic meters, that's when we'll start to shut this off, and that's where we need to come in with a rule to say if that range is true, then we are going to shut things off. So looking at close and then position up at 0 there. So that's it for that piece. I've gone ahead and run these simulations looking at the cumulative flow and some of the results associated with it. So we can see here I've got both the sluice gates here. I've got the level in the node. So we can see here we're starting off at 12.82, so we're able to get through some flow coming from the first sluice gate. We can see here we've got a rainfall intensity that quickly gets up to that 4 millimeters per hour, and that's when we see the regulator starting to shut down and the opening start to close to 0. At that point, that's when we trigger the new amount of flow going through here, or through the, I guess, the second sluice gate, where we've got that open with the regulator state being at that 0.5 meters, and then we can see the flow coming out of it as well. It's not absolutely perfect, just because of the incremental time that it takes to open and close those, but we're pretty close on the volume to that 350 that we specified before. And you can see here, up until that point, where we're at roughly the 1 hour and 20 minute mark, correlates to that same point over here where we see the head beginning to build up in the node up to that point that it can then spill over into the overflow weir. So wrapping up here, always be intentional about what you're trying to accomplish when you're building out those RTCs, and certainly use the validation and descriptions to just read through that, make sure what you think is going to happen actually does happen, pulling up graphs and things like that as well, to make sure that the timing makes sense and it's what you would expect would happen. And then of course there are more tutorials in the help manual for more practice with these.